All right, so this video is going to discuss the ideal gas law. First of all, there are no such thing as ideal gases. However, there are some gases that come pretty close. In the ideal situation where gas molecules don't attract or they don't occupy volume, it turns out the pressure of the gas times the volume of the gas is equal to the number of moles of gas times a constant times the temperature in Kelvin. So you do have to be aware of the units of R here whenever you're working one of these problems. And of course, R being a fundamental constant is something you'd always be given on an exam. And so the one we will use volume units are in liters, pressure units will be in atmospheres, moles, and the temperature has to be in Kelvin. The temperature has to be in an absolute scale of some sort. Of course, Kelvin is pretty much the only one scientists use. So what that means is all these other quantities have to be in the corresponding units that R is in. All right, so these are real simple problems. It's a nice, simple equation to solve, and it has 5 numbers, and if you're given 4, you can solve for the last. And so let's write down a typical problem. Okay, so we'll have some laughing gas, N2O, and let's say we have 0.350 moles of laughing gas, and it's at 22 degrees centigrade. All right, well, first of all, it's not the correct temperature unit. We add 273 to get Kelvin, and so that's 295 Kelvin. All right, and what else are we going to need? Let's see. We're going to be solving for the pressure, so this is the thing we're going to solve for. So we need a volume, and that's pretty much it. So the last thing we need to know is the volume. It's a 5 liters container. And so what is the pressure? Okay, so now you can either put in all the numbers into the equation and then solve for the unknown variable, or you can solve for the unknown variable first and then substitute. So what I'm going to do is do the algebra first for the equation. I'm going to solve this equation for pressure. Basically divide both sides by volume.